Shout out to Cliff Isaiah Godito. Thank you very much for your comment in my video. Another shout out to Nashria Dumagpik for commenting in my YouTube video. Thank you so much. Good day, class. Welcome to the third module of the third quarter, version 5 of grade 10 mathematics. Illustrating combination of objects. I am your teacher, Anthony G. Arisgado, Teacher 3 of Bukidnon National High School. Are you ready? Let's go! For the objectives of today's lesson, at the end of this session, the learners would be able to illustrate the combination of objects with and without repetition, and determine the number of combination of objects given the formula. What is combination? A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In combinations, you can select the items in any order. In case you didn't catch that, take note that for combination, the order of the selection does not matter. In combinations, you can select the items in any order. Two types of combination. Without repetition. Example, the lottery. Say the 649 lotto, where there are 6 numbers to be drawn out of 49 numbers. For example, the first number is 11, the second 9, the third 32, the fourth 40, the fifth 26, and lastly 13. Combination with repetition. Example, the coins in your pocket or wallet or pouch, such as 3 1 peso, 4 5 pesos, and 2 10 peso coins. Okay? Now, for the example, number 1. How many possible combinations are there for the letters of the word love if taken 3 at a time? So, we can have, say, LOV. Then, of course, taking L first. So, we have LVO, LOE, LEO, LVE, LEV. And then, we can have O first, then V, then E. But, okay, these arrangements represent permutation. This is not a combination. So, how do combination works? So, say for example, we have LOV. It's just the same with LVO, OLV, OVL, VLO, VOL. These letters or these arrangements having a green line are the same with LOV. Okay? Another, for LOE, okay, we have the blue line. It's the same with LEO, OLE, OEL, ELO, EOL. Okay? Then for LVE, we have this yellow or orange line. Okay, the same with LEV, VEL, VLE, ELV, and EVL. And lastly, for OVE, OEV, so it's the same with it, VEO, VOE, EVO, EOV. So, in other words, the combination, the 3-letter combination from the letters of the word love are LOV, LOE, LVE, and OVE only. Okay? There are 4 combinations for the letters of the word love if taken 3 at a time. I hope you get that one. Now, let us have the combination formula. This is read as the combination of n objects taken r at a time. Sometimes, you may be able to find the representation n, c, R, or small letter N, capital letter C, and small letter R. It's just the same with the C and the quantity of N and R. Okay? So this is read as the combination of N objects taken R at a time equals N factorial divided by R factorial times the quantity of N minus R factorial, where N is greater than or equal to R. Now, I mentioned this earlier. Also, the N is the total number of objects and R is the number of combination asked. Let's take a look at the example 1 again. It says, how many possible combinations are there for the letters of the word love if taken 3 at a time? So we have the given N equals 4 and R equals 3 because that is the condition of the combination. Okay, these are formula and substitute our given. So we have the combination of 4 objects taken 3 at a time is equal to our dividend 4 factorial, our divisor 3 factorial times the quantity of 4 minus R factorial. Then we can simplify. 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 4 minus 3 is 1. Then so we'll just have there 1. And then we can divide. 3 divided by 3 is 1. 2 divided by 2 is 1. 1 divided by 1 times 1 is 1. So, the combination of 4 objects taken 3 at a time is just equal to 4. So, there are 4 combinations for the letters of the word love if taken 3 at a time. So, I illustrated to you how combination is arranged. And now, I also showed to you how we solve the combination. Okay, so using the formula. So, let's proceed to combination with repetition. Let's proceed to combination with repetition. So, here it is. It says any selection of R objects from A where each object can be selected more than once is called a combination of N objects taken R at a time with repetition. 2 combinations with repetition are considered identical if they have the same elements, repeated the same number of times, regardless of their order. If you want to learn more about this, you may visit this link in the internet. Okay, now for the example of combination with repetition. Anton sells 5 flavors of ice cream such as vanilla, chocolate, mango, ube, and durian. How many combinations are there if a customer can choose 3 flavors at a time with repetition? So this has a condition and it is with repetition. Let's arrange this. Okay. Let's have a V for vanilla, C for chocolate, M for mango, U for ube, and D for durian. So let's arrange, or let's take the combination of each flavor 3 at a time. So we have this: vanilla, chocolate, mango, vanilla, chocolate, ube, vanilla, chocolate, durian, vanilla, mango, ube, vanilla, mango, durian, then vanilla, ube, durian. Then we have chocolate, mango, ube, chocolate, mango, durian, chocolate, ube, durian, and mango, ube, durian. So these are the combinations. But according to the problem, you can have repetition. So since you're buying an ice cream, you can have 3 vanillas, right? So it's just like this. So the combination without repetition has 10, okay, 10 arrangements, and with repetition we have 25 arrangements. So how many combinations there are? Okay, 35 combinations for the 5 flavors of ice cream if taken 3 at a time with repetition. Okay, so let us proceed to combination with repetition formula. So this is our formula. The combination of n objects taken R at a time is equal to Our dividend is the quantity of n plus r minus 1 factorial. And our divisor, we have r factorial times the quantity of n minus 1 factorial, where n is greater than or equal to r. So it's just the same. But take note and please try to differentiate the combination with repetition formula from the combination without repetition formula. Okay, so let's use this formula to solve using the ice cream example. So this is the ice cream example. Anton sells 5 flavors of ice cream such as vanilla, chocolate, mango, ube, and durian. How many combinations are there if a customer can choose 3 flavors at a time with repetition? So we have our given, we have our total number of objects, 5 flavors, and the condition of the combination is 3 at a time, and then with repetition. So our formula is this one. Let's substitute. So the combination of 5 objects taken 3 at a time. Our dividend is the quantity of 5 plus 3 minus 1 factorial. Our divisor, 3 factorial times the quantity of 5 minus 1 factorial. Simplifying, we have 5 plus 3 is 8 minus 1, that's 7, so 7 factorial. Copy 3 factorial, 5 minus 1 is 4, and then factorial. Simplify further. Okay, simplify further. We have 7 times 6 times 5 times 4 factorial because we have a divisor of 4 factorial. Then 3 factorial is 3 times 2 times 1. And then we can divide 4 factorial divided by 4 factorial, that's 1. Also, we can divide 6 by 3 factorial. Okay, the combination of 5 objects taken 3 at a time is equal to 7 times 5. And that is equal to 35. Yes, exactly the same with the illustration. So there are 35 combinations for the 5 flavors of ice cream if taken 3 at a time with repetition. Did you get this one? I hope so. Let's proceed. Take note. Okay, so this is about differentiating the formulas of combination without repetition and the combination with repetition. Please mind this formula for us to solve. Okay, so let's go. Practice. There are 7 colors of the rainbow. How many different ways are to choose a group of 4 colors if repetition is allowed? Number 2, from a group of 12 teachers, how many different committees can be formed consisting of 5 members? Let's answer this practice. So there are 7 colors of the rainbow. The RGB, the red, orange, yellow, green, blue, indigo, and violet. So how many different ways are to choose a group of 4 colors if repetition is allowed? Okay, so we have the given. Our total number of objects, 7. Our condition for the combination is 4. So we have this formula. Substitute the combination of 7 objects taken 4 at a time. We have a dividend, the quantity of 7 plus 4 minus 1 factorial. And our divisor, 4 factorial times the quantity of 7 minus 1 factorial. Simplifying, so 7 plus 4 is 11 minus 1, that's 10 factorial. Copy 4 factorial, and then 7 minus 1 is 6, so 6 factorial in the divisor. Simplifying further, we have 10 times 9 times 8 times 7 times 6 factorial for 10 factorial. Then the 4 factorial is 4 times 3 times 2 times 1, copy 6 factorial. We can divide 6 factorial by 6 factorial, that makes it 1. We can divide 8 by 4 times 2, that's 1. Also, we have 9 divided by 3, so that is 3. So what's left, okay, is 10 times 3 times 7, and that is 210. Therefore, there are 210 combinations for the colors of the rainbow if taken 4 at a time with repetition. Okay, I hope this is clear with you. Number 2, from a group of 12 teachers, how many different committees can be formed consisting of 5 members? So we have this given, n equals 12, and then 5 members for each committee. No repetition, so we can make use of this formula of the combination without repetition. So, substitute. Combination of 12 objects taken 5 at a time is equal to our dividend, 12 factorial, our divisor, 5 factorial, times the quantity of 12 minus 5 factorial. Simplifying. Okay, so we have 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 factorial. Our 5 factorial is 5 times 4 times 3 times 2 times 1. Copy 7 factorial from 12 minus 5. Then we can divide 7 factorial divided by 7 factorial, that's 1. 12 divided by 4 times 3, that's 1. 10 divided by 5 times 2, okay, that's 1. So, the combination of 12 objects taken 5 at a time is equal to 11 times 9 times 8. And that is equal to 792. Therefore, there are 792 different committees may be formed consisting of 5 members from the 12 teacher class. I hope you understand this one, especially the practice number 1 and 2. Okay, for our assignment, please answer this. How many combinations can be formed out of 10 different pairs of shoes if only 4 pairs can be displayed in a rack? So imagine you are selling 10 different pairs of shoes. Okay. Also, number 2, Anna has 8 colors of thread from which she can choose 4 colors at a time to sew a torn pants. So the pants has 4 torn areas. If repetition is allowed, how many combinations of colors can be made? So, this is our assignment. I hope you'd be able to answer this and submit your answers to your math teacher. Thank you so much for watching this video. Again, I am Anthony G. Arisgado, Teacher 3 of Bukidnon National High School. Please LSS this video. Like and then subscribe to my channel and share the video. You can also comment for me to shout out your name in my next video. Thank you so much. Bye-bye.